Hi guys, welcome to lesson 210, change as a percent, the final lesson in chapter 2. Alright, so our objective for the day is that we can find the percent change and that I can find relative errors in linear and nonlinear measurements. So our essential understanding is you can find a percent change when you know the original amount and how much it has changed. So the percent change is the amount of change as a percent from the original amount. Now I am going to teach you guys an approach that is different from what the textbook teaches you. The approach I'm going to teach you is to use the exact same formula every single time, unlike the book. My approach, and this is the approach that you're going to use in your science classes when you find experimental errors, you are going to take the final amount minus the initial amount and divide by the initial amount. Now, if your number is positive, you have a percent increase. If your number is negative, you have a percent decrease. Okay? So, in the textbook, it tells you to do it two separate approaches, one for a percent increase, one for a percent decrease. I think that's kind of stupid, so we're going to just do one formula. It's always going to be final minus initial divided by initial. All right, so our first example, we have a shirt is on sale for $15.50. If the original amount was $23, what is the percent change? So we have the change is equal to final price $15.50 minus the initial price $23 divided by the initial 23. All right, so when you type that into your calculator, you get that C is equal to negative 0.326, which means it is a 32.6% decrease in price. All right, we have a negative number, it's a decimal, so we convert it to a percentage, and it's a decrease. All right, so now you buy a Charizard card for $15. After 9 years, the card is worth $32. What is the percent change? So we start off with our final price, 32, minus our initial, 15, divided by our initial, 15. Okay? Plug and chug, do the math. C is equal to 1.13. So this means you have a 113% increase in the value of the Charizard card, which I believe is some sort of Pokemon. All right, letter C. When the PlayStation 3 launched in 2006, it cost $499 for the basic model. On Black Friday last year, you could buy a PS3 for $149. I want to know what is the percent change of that price. So, final price, our change is equal to final $149 minus the initial $499 over the initial $499. So C is equal to negative 0.701, which means this is a 70.1% decrease in price. All right. If you go on to the next page, I want you guys to try letter D on your own. In 1990, there were 1,330 registered alpacas in the United States. By 2008, there were 53,000. What is the percent change of the giraffe sheep? So, we start off with our final 53,000 minus our initial 1,330, and we are dividing it by our initial 1,330. All right. Subtract 53,000 minus 1330, and then divide it by 1330, and we find that C is equal to 38.8, which means it is a 3,880% increase in the population of alpacas in the United States over a 18-year span. Okay. All right, problem number 3, finding percent error. We have a formula for that. And what it is we are going to take the measured or estimated value and subtract the actual value from it and take the absolute value. So these will all be positive numbers. And then we divide it by our actual. All right, so this would be, for example, if you are measuring things in chemistry and you know the actual value of it, you can see the difference. All right, so you estimate your weight at 170 pounds, not points. Didn't catch that. After you weighed, you find your actual weight is 176 pounds. What is the percent error? So our error is equal to the absolute value of your estimated 170 minus the actual 176, all divided by 176. So our E is equal to 0.034, which is a 3.4% error. Okay. We don't care that it's high or low, we just care the percent. How far off were you from your measurement? So it's 3.4% off. All right, why don't you guys try letter B. You estimate that your school is about 45 feet tall. Your school is actually 52 feet tall. What is the percent error? So we have our error is equal to our estimated 45 minus our actual 52 divided by our actual 52. So E is equal to 0.115. And these are rounded figures, guys, so you feel free to round. And that means it is an 11.5% error. Okay. Lastly, problem 4, finding minimum and maximum dimensions. And what we're told is that your measurement error could be as much as half of the measuring unit above or below. So you could be off by as much as half the unit. If you're off by more than half a unit, you're not a very good measurer. All right, so a puppy is weighed in at 13 pounds to the nearest half pound. We want to know the minimum and maximum weight for that puppy. So it could be somewhere up to a half a pound off of its value. So our minimum is going to be the weight of the puppy minus half a pound. Well, you could be up to as much as half of your measuring unit. So half of a half pound is a quarter pound. So your puppy could be a quarter pound lighter than 13. So 13 minus 0.25 would be 12.75 pounds. Your maximum weight for your puppy is going to be that 13 pounds plus the potential error, which is 0.25. And that's all you have to do for that. All right. Letter B, a student's height is measured at 66 inches to the nearest inch. So half of the nearest inch would be a half inch. What are the student's maximum and minimum heights? So we have min is going to be 66 minus 0.5, which is 65.5 inches. The max is going to be 66 plus 0.5, which is 66 0.5 inches. That's all you need to do for this section. All right, we're going to be skipping problem 5 this year, and that is the end of our lesson. So make sure you rate your level of understanding. 1 is lost, 4 is I could teach this lesson. Fill out your summary. What did we learn? What skills did you learn? And then again, make sure you write down any questions you may have developed as we went through the lesson. And this is the final lesson in Chapter 2, so we're going to get ready to study for the test the rest of the week. All right, have a good night.